I was just figuring out, making sure it was recording. Okay. I'm Irene Prado. My presentation is on distributed automation with an IEC 61499 programming standard. I don't know how much experience you have with programming. Do you have any?
A little, not much.
A little bit. Okay, so this standard differs a little bit from kind of normal programming. Normally, when you think programming, you think I'm going to be typing in strings of code. This programming standard actually relies on function blocks, and each function block has a specific thing that it does. Some of them are timers, some of them run multiplexing, so a kind of choice-based system. So this is a really kind of intuitive system that it has a little bit of a learning curve, but it can be used by many people who don't have kind of a programming background.
Yeah.
And the cool thing about it is an open source programming language, meaning that it can fit with any kind of hardware and can couple with other kinds of software as well. So that it's not necessary to kind of say, it's not like having, if you have a Mac, you have to use an iPhone to make it, sync up well, right? That's kind of one of the problems with a lot of equipment today, is it has to be synced with specific other equipment. This programming language, because it is open source, means that it can work with pretty much anything. I explored it specifically in the mindset of an automated system. And this could be any kind of automated system, like factories, even cars, anything that has a bunch of sensors that all have to talk to each other, and data that has to be analyzed. Right. So one of its major uses, one of its major applications would be in automated factory floors, where best of use product is important. You want your best equipment in order to give you the best information.
So what does it do? Because now we have Amazon that has these, the floor, they have the robots that does the sorting and picking and packing for them now. So how does that fit into an industry where it's already computerized? What would something like this do?
Well, what this would do is it would take the place of the current software. And it doesn't necessarily take the place of all the software. It can take place of units of the software. But what this means is it can interface with anything. Because like I mentioned earlier, sometimes certain equipment has to be interfaced with the right software or else it won't work.
Right.
This kind of means that it'll work with anything. And it's unique in the sense that it can be downloaded onto any piece of hardware. So even if the hardware itself doesn't originally come with the software or the platform, it can immediately go on there and be preset. So I use this specifically with a Raspberry Pi, which is a small, basically a small computer board. And so I used it with a discrete system. This was a conveyor and punch machine, which you can't see in the next slide there. You can see right down here, I've got a conveyor belt and a punch machine. Now this system has 4 input-output devices connected to it. Now, originally it was all programmed on one board. I took the opportunity to explore this programming language a little bit more and separated the programming into 2 distinct nodes. Now, these nodes can talk to each other freely using the programming language. And so the input-output devices have no problem communicating. What this would mean on like a factory floor is like you've got lights, you've got sensors, you've got all sorts of input-output devices that have to talk to each other, but sometimes they're far apart. So what this means is wirelessly, I could have a bunch of boards for a cluster of instruments in one corner, speaking to another cluster of instruments that's in a totally different location on the factory floor, and they can seamlessly communicate. And again, as I mentioned earlier, they don't have to be from the same company. They could be from a whole host of different companies, a whole host of different brands, and communicate seamlessly. Again, I did a very small system using a Raspberry Pi. But like I said, I broke up the input output devices and created this, and I mapped my program to each device. Another unique aspect of this programming language is that I can create one program, and that's all I did. Like, this is a single program, but you can see the color differences here, meaning that it was mapped to 2 different nodes. Meaning I can make one program, and then I can immediately say, okay, this cluster of instruments needs this part of the program. This cluster needs this part. And uniquely, if I need to change out that node, all I have to do is go into it and say, put in a different IP address. And it automatically changes the node. So if my Raspberry Pi breaks and I need to put another one, it's not that I have to go in and map the whole thing again. I just have to change the IP address of the program and it automatically does it. So it's really adaptable and flexible. I think that's one of the key things I brought out from this is it's really adaptable and it's really flexible. There was a learning curve. It took a little bit of learning what each part does, what each block can do. But once I figured that out, I was able to kind of understand exactly what this programming language can do and what it can offer. So yeah, do you have any questions?
No, you answered my question. My question was basically about how would a program like this run in the Amazon setting or one of the warehouses like that, Amazon UPS or USPS and stuff like that.
Yeah, so it would be mapped, clusters of, like, each robot would have its own node, and they would each be able to talk to each other, and something breaks in that node, again, map it to a new node, and you're good to go. So
is it more, if I may, is it more an intranet situation, or could it go onto the internet?
This is like, this system specifically is a distributed control system. So while it can interface through the internet, what my application here was wireless communication, not through the internet.
Okay, yeah, excellent. So is there a distance barrier associated with the wireless, or just wireless nodes limit?
I did not test for distance application. From what I understood and what I researched is that there isn't. As long as they're connected to a wireless network of some kind and all of them linked, they're fine. They don't need the internet to interact, but as long as they're, and in this case, generally one would serve as kind of a wireless hub.
Absolutely.
Central hub, and then every node talks through that hub.
Okay, and just a last little question, and I missed the first little part, but would you anticipate that Bluetooth might work the same?
I was gonna ask.
Bluetooth has a lot of restrictions with it.
Okay.
Normally, you can only interface with 1 or 2 devices. There's also distance. Bluetooth definitely has distance restraints.
Yeah.
So this, because it's its own wireless hub, essentially doesn't quite have the same restraints.
Very nice. Very nice. Thank you for recording too. Does anybody else have a question? That's excellent. Okay, I'm leaving you for another group.
You're in the group chat, right? You're in the I feel like you're in the
Riley's
essay group. Yeah, in Riley's group. Yeah.
Yeah, I sure am.
Okay.
Well, this is a pretty